Cylinder head sector, also known as CHS, was an early method for giving addresses to each physical block of data on a hard disk drive. In the case of floppy drives, for which the same exact diskette medium can be truly low-level formatted to different capacities, this is still true. Though CHS values no longer have a direct physical relationship to the data stored on modern storage media except for floppy disks, virtual CHS values are still being used by many utility programs and file systems. Definitions: CHS addressing is the process of identifying individual sectors on a disk by their position in a track, where the track is determined by the head and cylinder numbers. The terms are explained bottom-up. For disk addressing, the sector is the smallest unit. Disk controllers can introduce address translations to map logical to physical positions. For example, zone bit recording stores fewer sectors in shorter tracks. Physical disk formats are not necessarily cylindrical, and sector numbers in a track can be skewed. Tracks: the tracks are the thin concentric circular strips of sectors. At least one head is required to read a single track. With respect to disk geometries, the terms track and cylinder are closely related. For a single or double-sided floppy disk, track is the common term, and for more than two head, cylinder is the common term. Strictly speaking, a track is a given CH combination consisting of SPT sectors, while a cylinder consists of SPTA, H sectors. Cylinders: a cylinder is a division of data in a disk drive, as used in the CHS addressing mode of a fixed block architecture disk, or the cylinder a Eurohead a Euro record addressing mode of a CKD disk. The concept is concentric, hollow, cylindrical slices through the physical disks, collecting the respective circular tracks aligned through the stack of platters. The number of cylinders of a disk drive exactly equals the number of tracks on a single surface in the drive. It comprises the same track number on each platter, spanning all such tracks across each platter surface that is able to store data. Cylinders are vertically formed by tracks. In other words, track 12 on platter 0 plus track 12 on platter 1 etc. is cylinder 12. Any track comprising part of a specific cylinder can be written to and read from while the actuator assembly remains stationary, and one way in which hard drive manufacturers have increased drive access speed has been by increasing the number of platters which can be read at the same time. Other forms of direct access storage device, such as drum memory devices or the IBM 2321 data cell, might give blocks addresses that include a cylinder address, although the cylinder address doesn't select a cylindrical slice of the device. Sectors: a sector is the smallest storage unit that is addressable by a hard drive, and all information stored by the hard drive is recorded in sectors. Floppy disks and controllers use physical sector sizes of 128, 256, 512 and 1024 bytes, whereby formats with 512 bytes per physical sector became dominant in the 1980s. The most common physical sector size for hard disks today is 512 bytes, but there have been hard disks with 520 bytes per sector as well for non-IBM compatible machines. In 2005, some Seagate custom hard disks used sector sizes of 1024 bytes per sector. Advanced format hard disks use 4096 bytes per physical sector since 2010, but will also be able to emulate 512 byte sectors for a transitional period. Magneto-optical drives use sector sizes of 512 and 1024 bytes on 5.25-inch drives and 512 and 2048 bytes on 3.5-inch drives. In CHS addressing, the sector numbers always start at 1, there is no sector 0, 1, which can lead to confusion since logical sector addressing schemes typically start counting with 0. For physical disk geometries, the maximal sector number is determined by the low-level format of the disk. However, for disk access with the BIOS of IBM PC-compatible machines, the sector number was encoded in 6 bits, resulting in a maximal number of 63 equals 64 minus 1 sectors per track, where 64 equals 26 corresponds to 6 bits. The maximum 63 is still in use for virtual CHS geometries. Blocks and clusters: the Unix communities employ the term block to refer to a sector or group of sectors. For example, The Linux FDISK utility normally displays partition table information using 1024-byte blocks, but also uses the word sector to help describe a disk size and the phrase, 63 sectors per track. Clusters are allocation units for data on various file systems, where data mainly consists of files. Clusters are not directly affected by the physical or virtual geometry of the disk, that is, a cluster can begin at a sector near the end of a given CH track, and end in a sector on the physically or logically next CH track. Heads. A device called a head reads and writes data in a hard drive by manipulating the magnetic medium that composes the surface of an associated disk platter. Naturally, a platter has two sides and thus two surfaces on which data can be manipulated. Usually there are two heads per platter, one per side. The CHS addressing supported in IBM PC-compatible BIOS code used 8 bits for, theoretically up to 256 heads counted as head 0 up to 255. However, a bug in all versions of Microsoft DOS PC DOS up to including 7.10 will cause these operating systems to crash and boot when encountering volumes with 256 heads, too. Therefore, all compatible BIOSes will use mappings with up to 255 heads only, including in virtual 255A, 63 geometries. This historical oddity can affect the maximum disk size in old BIOS INT 13 hours code as well as old PC DOS or similar operating systems, 512 bytes sector, a 63 sectors track, a 255 heads, a 1024 cylinders, equals 8032.5 MB, but actually a 256A, 63A, 1024 equals 8064 MB yields what is known as ATA GIB limit. In this context, relevant definition of ATA GIB equals 8192 MB is another incorrect limit, because it would require CHS 512A, 256A, 64 with 64 sectors per track. Tracks and cylinders are counted from 0, that is, track 0 is the first track on floppy or other cylindrical disks. Old BIOS code supported 10 bits in CHS addressing with up to 1024 cylinders. Adding 6 bits for sectors and 8 bits for heads results in the 24-bit supported by BIOS interrupt 13 hours. Subtracting the disallowed sector number 0 in 1024A, 256 tracks corresponds to 128 MB for a sector size of 512 bytes. And 8192 minus 128 equals 8064 confirms the ATA GIB limit. CHS addressing starts at 01 with a maximal value 102,363 for 24 equals 10 plus 8 plus 6 bits, or 102,363 for 24 bits limited to 255 heads. CHS values used to specify the geometry of a disk have to count cylinder 0 and head 0 resulting in a maximum 102,463 for 24 bits with 255 heads. In CHS tuples specifying a geometry S actually means sectors per track, and where the geometry still matches the capacity the disk contains S sectors. As larger hard disks have come into use, a cylinder has become also a logical disk structure, standardized at 16A065 sectors. CHS addressing with 28 bits permits 8 bits for sectors still starting at 1, that is, sectors 1 are Euro 255, 4 bits for head 0 are Euro 15, and 16 bits for cylinders 0 are Euro 65,535. This results in a roughly 128 GIB limit. Actually 65,536A, 16A, 255 equals 267,386,880 sectors corresponding to 130,560 MB for a sector size of 512 bytes. The 28 equals 16 plus 4 plus 8 bits in the ATA2 specification are also covered by Rolf Brown's interrupt list, and an old working draft of this now expired standard was published. With an old BIOS limit of 1024 cylinders and the ATA limit of 16 heads, the combined effect was 1024A, 16A, 63 equals 1,032,192 sectors, that is, a 504 MB limit for sector size 512. BIOS translation schemes known as ECHS and revised ECHS mitigated this limitation by using 128 or 240 instead of 16 heads, simultaneously reducing the numbers of cylinders and sectors to fit into 102,463 or 102,463 for the given total number of sectors on a disk. CHS to LBA mapping. CHS tuples can be mapped onto LBA addresses using the following formula: A equals N sectors plus, where A is the LBA address, NHEADS is the number of heads on the disk, and sectors is the number of sectors per track, and is the CHS address. A logical sector number formula in the ECMA 107 and ISO IEC 9293/1994 standards for FAT file systems matches exactly the LBA formula given above. Logical block address and logical sector number are synonyms. The formula does not use the number of cylinders, but requires the number of heads and the number of sectors per track in the disk geometry, because the same CHS tuple addresses different logical sector numbers depending on the geometry. Examples: for geometry 10-20-16-63 of a disk with 1,028,160 sectors, CHS 321 is LBA A3150 equals opening round bracket 3 times A16 plus 2 closing round bracket times A63. For geometry 1008-4255 of a disk with 1,028,160 sectors, CHS 321 is LBA A3570 equals opening round bracket 3 times AA4 plus 2 closing round bracket times 255. For geometry A64-255-63 of a disk with 1,028,160 sectors, CHS 321 is LBA 48,321 equals opening round bracket 3 times 255 plus 2, A63. For geometry 21-42-15-32 of a disk with 1,028,160 sectors, CHS 321 is LBA A1504 equals opening round bracket 3 times A15 plus 2 closing round bracket times A32. To help visualize the sequencing of sectors into a linear LBA model, note that the first LBA sector is sector 0, the same sector in a CHS model is called sector 1. All the sectors of each head track get counted before incrementing to the next head track. All the head tracks of the same cylinder get counted before incrementing to the next cylinder. The outside half of a whole hard drive would be the first half of the drive. In 2002, the ATA6 specification introduced an optional 48 bits logical block addressing and declared CHS addressing as obsolete, but still allowed to implement the ATA5 translations. Unsurprisingly, the CHS to LBA translation formula given above also matches the last ATA5 CHS translation. In the ATA5 specification, CHS support was mandatory for up to 16 A514 A064 sectors and optional for larger disks. The ATA5 limit corresponds to CHS 16,383/1663 or equivalent disk capacities, and requires 24 equals 14 plus 4 plus 6 bits. History: earlier hard drives used in the PC, such as MFM and RLL drives, divided each cylinder into an equal number of sectors, so the CHS values matched the physical properties of the drive. A drive with a CHS tuple of 50432 would have 500 tracks per side on each platter, 2 platters, and 32 sectors per track, with a total of 32 A768 A000 bytes. ATA IDE drives were much more efficient at storing data and have replaced the now archaic MFM and RLL drives. They use zone bit recording, where the number of sectors dividing each track varies with the location of groups of tracks on the surface of the platter. Tracks nearer to the edge of the platter contain more blocks of data than tracks close to the spindle, because there is more physical space within a given track near the edge of the platter. Thus, the CHS addressing scheme cannot correspond directly with the physical geometry of such drives, due to the varying number of sectors per track for different regions on a platter. Because of this, many drives still have a surplus of sectors at the end of the drive, since the total number of sectors rarely, if ever, ends on a cylinder boundary. An ATA IDE drive can be set in the system BIOS with any configuration of cylinders, heads and sectors that do not exceed the capacity of the drive, since the drive will convert any given CHS value into an actual address for its specific hardware configuration. This, however, can cause compatibility problems. For operating systems such as Microsoft DOS or older version of Windows, each partition must start and end at a cylinder boundary. Only some of the most modern operating systems may disregard this rule, but doing so can still cause some compatibility issues, especially if the user wants to perform dual booting on the same drive. Microsoft does not follow this rule with internal disk partition tools since Windows Vista. See also, cylinder, CD-ROM format, block, disk storage, disk formatting, file allocation table, disk partitioning, references, ABC volume and file structure of disk cartridges for information interchange. Standard ECMA 107. ECMA. 1995. Retrieved July 30, 2011. Standard floppy disk format supported by MS-DOS. KB 75131. Microsoft Knowledge Base May 12, 2003. Retrieved July 31, 2011. Western Digital Euro unregistered trademark S advanced format, the 4K sector transition begins. Anand Tech. December 18, 2009. Retrieved July 29, 2011. Advanced format technology brief. Hitachi 2010. PA1. Retrieved August 1, 2011. 512-byte emulation is sometimes referred to as 512EA. ABC Andres Broer. History of BIOS and IDE limits. Large disk HOWTOV 2.5. Retrieved July 30, 2011. Windows NT 4.0 supports maximum of 7.8 GB system partition. Microsoft. February 23, 2007. Retrieved July 30, 2011. 5K 500B SATA OEM Specification Revision 1.2. Hitachi March 17, 2009. PA51. Retrieved July 29, 2011. ATA2. X3T10/0948D. INSIT's Technical Committee T1380 Attachment March 18, 1996. Retrieved July 30, 2011. ATA1. X3T10/791D. INSIT's Technical Committee T10SCSI Storage Interfaces 1994. Retrieved July 30, 2011. AB Information Technology, Volume and File Structure of Disk Cartridges for Information Interchange. ISO IEC 9293 1994. ISO Catalog. 1994. Retrieved January 6, 2012. AB Information Processing, Volume and File Structure of Flexible Disk Cartridges for Information Interchange. ISO 9293 1987. ISO Catalog. 1987. Retrieved January 6, 2012. ATA6. T13/1410D. INSIT's Technical Committee T1380A Storage Interface. 2002. PA22. Retrieved July 30, 2011. In standards ATA PI5 and earlier, a CHS translation was defined. This translation is obsolete but may be implemented as defined in ATA PI5. ATA5. T13/1321D. INSIT's Technical Committee T1380A Storage Interface. 2000. PA19. Retrieved July 30, 2011. If the DVC Euro unregistered trademark S capacity is greater than or equal to 1 sector and less than or equal to 16,514,064 sectors, then the device shall support CHS translation. KB 931760. Microsoft Windows XP support. Microsoft Knowledge Base July 23, 2009. Retrieved July 30, 2011. Notes, 1. This rule is true at least for all formats where the physical sectors are named 1 upwards. However, there are a few odd floppy formats, where the first sector in a track is named 0 not 1. 2. While computers begin counting at 0, DOS would begin counting at 1. In order to do this, DOS would add a 1 to the head count before displaying it on the screen. However, instead of converting the 8-bit unsigned integer to a larger size first, DOS just added the 1. This would overflow a head count of 255 into 0 instead of the 256 that would be expected. This was fixed with DOS 8, but by then, it had become a de facto standard to not use a head value of 255. External links, hard disk backup, repair, and data recovery.